The Karl nuclear power test plant began operations as the first commercial nuclear power plant in the Federal Republic of Germany in 1961. In 1985, the 16-megawatt boiling water reactor was shut down, having produced 2,000 gigawatt-hours of electricity during 150,000 hours of operation. Dismantling and disposal of contaminated and radioactive systems and major components in the controlled area has been in progress since 1992. RWE Nuchem took over dismantling and decommissioning operations in 2001. The goal is complete removal of the facility and release of the site from nuclear regulatory control. Following dismantling of the reactor pressure tank, the reactor pit and the concrete of the biological shield are now exposed. Due to its proximity to the reactor core, the concrete and the reinforcing rods and shield cooling pipes inside it were exposed to neutron radiation over the years and are now radioactive. Measurements taken by the Radiation Safety Service revealed dosage rates of 4 millisievert per hour in the center of the reactor pit. Radioactivity levels in the core zone were determined on the basis of bore samples: 4,600 becquerel per gram based on europium-152 for the concrete, and 8,806 becquerel per gram based on cobalt-60 for the metal components. These values necessitated the use of remote dismantling techniques to remove the biological shield. Intensive advanced planning is required before application documents for this dismantling project are prepared and submitted. The time required for review of these documents by the regulatory authority is used to procure or order the manufacture of suitable equipment. A one-to-one replica of the biological shield is available as a model. Numerous tests are conducted on this model: concrete wall sawing and cable sawing, core drilling, water jet cutting and earth-moving operations with a small excavator. The results of these tests indicate that a remote-controlled demolition unit, equipped as needed with a chisel or hydraulic shears, is the best solution in terms of demolition speed, dosage minimization, avoidance of cross-contamination and disposal. Personnel to be assigned to dismantling operations undergo rigorous training. Employees receive instruction in the tasks to be performed and their significance with respect to radiation and occupational safety. The team assigned to operate the demolition equipment is trained on the replica of the biological shield and also tests the equipment itself. A waste monitoring system used to measure the radionuclide concentration is being calibrated. Before long, all the equipment is tested, the team is ready, and all required equipment has been installed in the reactor building. The small excavator is now being brought into the controlled area and positioned in the reactor pit. The rotating cover used during power plant operations isolates the biological shield from the building ventilation system. A newly installed filtered air extraction unit with a flow rate of 8,000 cubic meters per hour immediately removes the dust raised during demolition. Thus, the remote-controlled equipment operators always have clear vision on their monitors. Demolition equipment operation requires a high level of concentration. The monitors provide only a two-dimensional view. Whether working with the chisel or the hydraulic shears used to cut the reinforcing rods and shield cooling pipes, operators must proceed with great care and precision at all times. Tool changes and required maintenance work are performed outside the area exposed to radiation. Some manual labour is still needed when it comes to filling and transporting the accumulated waste material. A funnel-shaped collection and filling unit has been installed beneath the reactor pit. Lead shielding and stone partitions ensure the safety of personnel assigned the task of filling the waste material into 200-litre barrels. Since there is also a high risk of dust incorporation in this zone, employees are required to wear protective clothing and masks when entering the area. This room is also connected to a separate ventilation and exhaust system. The barrel is then filled, moved out through the discharge gate and cleaned. Following a wipe test, it goes to the barrel testing unit where the dosage rate is measured. Newly installed lifting equipment lifts the barrel from the depths of the reactor building to the +3 metre level and places it on a roller conveyor. This roller conveyor in the former material discharge unit serves as a buffer zone for further waste treatment. With its special exhaust filter system and housing, this room, where the fuel element storage basin was once located, is ideally suited for the work of transferring the waste material from barrels to Type 4 permanent safe storage containers. Waste material is emptied from the barrels using a remote-controlled barrel manipulator. Personnel contact with loaded containers is required only for final sealing. The loaded containers are stored in a pre-transport storage room. Once all documentation is complete, they leave the Carl nuclear power test plant for the Mittertage interim storage facility in 20-foot containers. The biological shield has been totally dismantled in only 6 months. Impressive proof once again that a team of qualified specialists can dismantle a nuclear power plant safely even after 25 years of operation.